Good morning, ladies and gentlemen, and welcome once again to the course on Managed Aquifer Recharge Systems and Water Harvesting Techniques conducted by the University of Sassari and the Maya project. In the third lecture, we'll talk about MAR passive and intermittent systems, the detention-infiltration and the retention-infiltration systems, the combinations of water from different sources, some examples of reuse, legal aspects, exercises, and additional materials. Managed aquifer recharge intermittent, temporal, or of opportunity systems are in general passive systems. They work especially when some extreme water-related event occurs and are usual in arid and semi-arid areas, with eventual flooding events. I remind that the passive system is that one which does not require electricity to work. Dikes are key elements for MAR passive intermittent systems and for water harvesting too. They slow down the energy of the water. They get a volume detention, retention, and infiltration. They are either surface or underground systems, and they have multiple designs, either drilled or made of gabions, etc. Once again, one detention-infiltration system stops the water and infiltrates a part of it, and one retention system, once stops the water, retains it for its latter infiltration. The actions against extreme water-related events have been grouped in three chapters: droughts, overfloods, and actions in urban areas. Talking about droughts, it's important to remind the tale of the ant and the cicada. The ant was working the whole summer to have some food during the winter time, and the cicada was playing the guitar and napping, and when the winter came, she starved. So there is an analogous situation to store water in the aquifers or to do as a cicada. Managed aquifer recharge, or MAR, has demonstrated a great cost-effectiveness with regard to big hydraulic constructions. It is still in an incipient stage in much of the world, is specifically regulated in at least 12 countries, and is also a driving force. In the MAR project was developed one inventory of 24 different typologies or devices for MAR facilities. It is accessible in the link below. This is the second part of this inventory. Regarding overfloods, a recurrent problem in the Mediterranean area since 6 million years ago, it is based on water and forest management plus territorial planning measures and combined actions from upstream watershed to the sea. There are 6 different techniques, including in this chapter. The first of them is the afforestation and silviculture practices to enhance recharge. By means of orderly runoff, structures designed according to infiltration rates. There are some examples where the infiltration in forested area is even 20% higher than in barren areas. The second one is the mechanized preparation of soil to increase the infiltration rate. The actions are conducted to minimize runoff, increase the recharge, and further planting. Here is an example of contour bands regarding this previous example. In relation to forest planning, the actions are related to the selection of appropriate species, planning and sustainable management of water in the forest, and good practices in the forests, enhancing the recharge of the aquifers. The fourth group of measures is based in the design, restoration, and maintenance of terraces. There are some specific structures called boqueras. They don't even have one translation into English, which are long furrows which divert high volumes of water in the overflow, taking it towards croplands. The second structure, also without translation into English, is atochadas. They are some structures made of sand, furrows, and dikes close to the basin flow direction with lateral diversions to store temporarily water in the terraces. They are based on the Roman principle divide et impera. Water runoff strengthen measures based on the diversion of river water towards proper forest, decreasing the runoff volume, speeding up the recharge rates, stretch on and delay the time of concentration, and involve the whole forest in the process. By last, the lamination and retention dikes as recharging structures in rivers. They slow down the concentration time, enhance the aquifer recharge, and cause imminent clogging problems. Another additional technical solution sample is the deep borehole for Mar next to an irrigation dam used to recharge the aquifer even 100 liters per second during the overflow. They ensure the pond construction and divide the overflow, reducing its devastation effect. Again, the Roman principle divide et impera. Actions in urban areas tend to reduce the runoff volume and breaking the heat island effect. Some good practices to minimize the surface runoff in cities are drainaging towards green areas, storing rainwater for a later use, and the growing use of sustainable urban drainage systems, or SADs. In respect to the combinations of water from different sources and for different uses, we have chosen the sample Alcazar-en-Pedrajes in Los Arenales Aquifer in Spain, diversifying water sources either from Pirón River or from a runoff canal or directly from a wastewater treatment plant. So operativity does not rely on water excess and permissions, and the combination from three different sources of water of different quality and in different proportion allows applying the principle dilution as a solution to pollution. Another example of reuse is the Satmar and runoff traps for irrigation in Daejeon, South Korea, where water is taken from the greenhouse roofs and also from reclaimed water and used for strawberries irrigation. Another good example for MAR, in this case for SATMAR, is in Adelaide in Australia, also for aquifer replenishment using water from the wastewater treatment plant and combining it with wells, boreholes, and infiltration ponds. Regarding MAR legal aspects, some actions willing to face legal constraints are the lack of an homogeneous definition for artificial recharge, the theoretical insufficient experience on artificial recharge, the control of the operation, surveillance, monitoring, etc., and ensuring a certain continuity of the experiences. Some future lines of action to be regulated applies for the demand of a unique and specific regulation for MAR definition in the whole Europe, including at least the following aspects. One specific procedure for authorizations. Artificial recharge cannot be considered and spill any longer. The financial aspects for artificial aquifer recharge are missed in the regulations, and the viability study for each case to check whether the proposed technical solutions are legal and viable should be applied prior its construction. At the end of this rapid presentation, I want to propose an exercise integrating the topics 1 to 3, treating the evolution of the system towards multifunctionality. The background of the area is presented with a virtual visit to the area, and new elements must be proposed by students, either passive or active, with comments and which elements are rejected from multifunctionality. As additional materials, there are 3 references and a set of videos and deliverables from different European projects. So I'll see you next week. Good luck. Thank you.